everyone to tonight's presentation of the New York Technology Council. Delighted to have you here. I want to thank our sponsors. It may sound trite, but without them we wouldn't be here. We've got 3 more coming next month. So we continue to add sponsors and appreciate all the support they provide to us. I want to thank Tengen for hosting us, and let me turn it over to Jamie Fitzgerald, who will be moderating the rest of the evening. Thanks again for coming.
Thank you, Eric. I'm going to pass this to you, Scott, which I guess means I'm going to ask you the first question. But before I do that, I'm just going to introduce myself and the rest of the panelists, and we'll get right into it. I'm Jamie Fitzgerald, the founder of Fitzgerald Analytics, which the simplest way to explain it is that we're a mixture of my strategy background with my obsession with data and analytics as a tool to achieve strategic objectives. And I became involved with NITEC when Don invited me to give a keynote on analytics and financial services back in 2011, and ever since then have been a big fan of the organization and involved when I can be. So today I'm really just here to ask questions of people with a lot more of a deep functional specialty in this space of cloud and analytics and use cases, but I do so with a background of more than 10 years helping clients to figure out how to A, link strategy and data, and B, implement the analytics component of that. So with that being said, I'd like to introduce Scott, who's the Eastern Region lead and client partner at Think Big. Interesting facts about Scott, aside from his bio, which you probably read, it's probably one of the reasons you're here right now, is he was the captain, I believe, of his high school math team, and apparently he's mature and grown up enough to admit that, or at least in this company, we're probably admiring that right now. And also a former partner at Accenture, now doing some really innovative stuff in big data strategy. So we're excited to have him. Edward.
Should we sit as we did?
Yeah, actually I was thinking that if you don't mind, if I could be so bold, Scott would sit there, you would sit there, and Stuart at the end. Edward Servan-Schreiber, who we've already met in his introduction of Tengen, the makers of MongoDB. It's hard to know where to start with him. I did some research. I do research on speakers before I moderate, and found a fascinating video in which Edward is speaking about the role of big data and analytics in sparking innovation in marketing, and he starts the talk somewhat surprisingly but really beautifully talking about the history of paper, invented in 108 AD, I think.
Yeah, in China.
In China, exactly. And then charting it through this technology and how it changed the ability to do new things, and also how it dramatically increased the, really democratized the ability to try new things, write poems, drink beer, and still write poems. That's part of the history, actually. So that was fascinating. And the other thing that I find interesting and also very timely about Edward is that in his career past, he spent a lot of time with telephone records, telecom data, and what they call CDR, or call detail records. Earlier today, Edward asserted to me that using that data alone, he could predict within days, if you just had your call records, whether you were falling in love and who you lived with. So maybe we'll talk about that later. You can hear me in the back, right? Yep. Okay, great. And so finally, we have Stuart Sim of PlaceIQ with us, who is living the practitioner reality of applying big data. He's been building and evolving the stack at PlaceIQ most recently. And a fun fact about him, which I'm just amazed by, is he says, well, my first job was building puppets, and it wasn't that good a job, and it didn't pay that much. But then you find out, wait, he was building puppets for Scott Henson Productions, as he was really building robots for Scott Hansen puppets, and as you know, those robots were used in movies like Jurassic Park. So in Jurassic Park 1, when you see the, what is it, a T-Rex?
T-Rex.
Chasing the human beings that are about to kill them, that's actually a robot that you built. So it's physically you built it, but also there's a whole algorithm about how that thing moves.
That's right.
So that sounds like a pretty cool first job, actually.
Yeah, it was fun.
So with that being said, let us move forward. I'm just going to quickly page through some slides, and the main goal of these slides is to encourage those of you who do like to tweet to do so. And so here you can see Scott Rose is just one @ sign away from tweeting the great things he says at Think Big A. You can live tweet Edward at these handles. You can live tweet Stuart at PlaceIQ. And if you didn't catch all of that, really the easiest thing, as you know, is the event hashtag. We're using the event hashtag NITEChdata. And if you follow that street, you'll find lots of good stuff. My colleague Carmen is the fastest typer I know, and she's live tweeting every 35 seconds. So we encourage you, if you like to tweet, to do so. No pressure. So that's the end of the intro. And maybe I'll leave it up to AV for what we'd like to leave in the background, maybe this. Okay, great. So we have limited time, so I'm going to try to move really quickly through some basic stuff that we really don't need to dwell on anymore. I think you're probably sick and tired of people spending 5 minutes defining big data or explaining why it's exciting without being specific. So clearly here we're going to talk about specifics about this phenomenon that involves, depending on who you talk to, a combination of massive explosion in size, massive explosion in complexity, in diversity, in speed of arrival of data. And you can think about it in a lot of ways. You can think about it as a change in technology, cheaper, faster, bigger processing and storage. You can think of it as a change in some algorithms certainly have made a big deal. You can also think of it as a business transformation where we're taking that technology and we're using it in different ways. And that's probably, in my opinion, I think you're talking to the panelists, that's where the hard stuff is, because the technology is there. And the question now is, how do we human beings make good use of what we built? So with that being said, let's see if we can get specific relatively quickly. And Mr. Rose, since you're holding the conch, what types of organizations can benefit, and how limited or constrained is that, and how diverse is that opportunity?
I honestly, I think it's only limited by the imagination of the people within the organization. I'd be hard pressed to look at an organization, any industry, that couldn't benefit from these technologies. Now, I mean, of course, it starts with understanding where those benefits come from. There's a wide range from, just pulling cost out of your data management infrastructure. You see a lot of organizations adopting the technology really to drive cost out of what they're doing around data warehousing. Interesting, I'm from Chicago, so Sears, big company, big retailer based there. The CTO has proclaimed that he wants to rid the organization of ETL. And he's trying to leverage Hadoop to do that. And of course, the big flip with Hadoop is it's structure on read as opposed to structure on write with traditional relational technologies. And so you see with a lot of organizations where if they have to go in and make a change, if one of the businesses wants to innovate around some analytic process or even a report, first it's a request, and then someone has to study the impact and the change to schemas, then it goes to committee, then someone has to implement it, and 8 months later, maybe something new happens. And so being able to, and so if you look at information management across an organization, they might be spending 80 or 90% of their budget on ETL and 10% on innovation. And if you can flip that, imagine how many, where you can drive value across the organization. I think even then you get into new types of data, multi-structured data, new analytic approaches, and lots of opportunities to create value there. So, an example we're even seeing here with clients in financial services where you sort of see a move back to looking at market semantics as a basis for trading activity, where, if you're old enough to remember Peter Lynch from Fidelity, who wrote a book called Beating the Street, and it was all premised on semantics, understanding meaning, invest in things you know, go down to your local mall and see which stores are doing well, see where teens are buying clothing, and use that as a basis for investment strategy. And a lot of trading over the last, say, 10 years moved to more syntax, right? Understanding flow, order flow, high frequency trading. Well, we're starting to hear people looking at going back to semantics, but writ large, right? So looking at
automated semantics.
No, but how would you look at logistics data across the globe and join that with weather data, and what does that mean for a trading strategy? And these are big data problems.
So to clarify, when you say moving back to semantics, moving back to meaning, yes, but in a new context that is automated or semi-automated or sort of
I think both. Yeah.
Both, right? You need to have sort of a conceptual framework.
Certainly a
technology.
research environment to do analysis against these types of data sets to develop trading strategies, and then systems that would allow you to put those strategies into production.
Interesting. So you mentioned this idea of the 10% that may be available, if we're lucky, in many large corporate environments to experiment and try new things. Here we're thinking about the cloud as a option, one of several options for where to do stuff with data. Maybe we can go to Edward. What are your thoughts on this sort of old versus new question, and how would you attack this problem of not having enough time or maybe money to do enough of the creative stuff that will actually help it more in the long run?
No, it's an enormous problem. The problem of everything is so heavy to move. It just feels like when these big organizations are trying to do anything, right? Say a retailer trying to introduce the weather into its operations, because they've noticed, big surprise, that if it rains, you're not going to buy the tank tops. If it rains, you're going to be interested in more rainy stuff. And that, can you imagine what that means? So that means if you have to integrate the stream of weather data, and that should influence essentially the front page of your website as a retailer, which means that somehow you have to tag all of your content as to whether it's appropriate for this kind of weather or this kind of weather. There's actually an enormous amount of data processing just to do what feels like a pretty trivial thing, right? But to do that is very hard. And these organizations are realizing you can digitize almost anything you want at this point. And they can do it, but then once they do it, then what? And their problem is that no one has the answers in terms of how to leverage this information, whether it's weather, whether it's logistics, whether it's speed, whether it's temperature. None of this, no one has the answers on how to do this best, so they have to try all kinds of things all the time. And try means that they're going to fail most of the time. And what does this mean? It means that if you're going to do this properly, you're going to have to enable a whole IT strategy, a whole enablement to allow people to try and fail cheaply and quickly. And on the off chance that you're going to try something that's actually useful, which, as we all know, happens only 1 out of 20 times, then you want to be able to scale that quickly. And scaling means that suddenly you're going to try something that is perhaps with 1,000 users, and within a few weeks it's got to be with 10 million. Well, there are not many infrastructures that can withstand that. Imagine you doing this with a building, right? It's like, oh, I have this interesting way to build, right? And it can host 20 people. And suddenly you're like, okay, now let's do this for 20,000 people tomorrow. It's not that easy. And the whole cloud enablement, our technology, the cloud is essentially trying this, right? You can imagine that in the 19th century when people were trying to build electricity, they were doing it in their basement. They were trying their own, okay, I'm going to make my own little power plant just for myself. And at some point that didn't scale. And electricity at some point went in the cloud. You had like these power generators and these power companies, and all you had to do was to plug yourself into them, and if suddenly you needed 100 times or 1,000 times more electricity, you just paid a bigger bill. You didn't have to build yourself a bigger plant. we're in the same situation.
Thank you, that's fascinating. And you're right, there's this analogy that you use of something starting out as build your own and going to be a utility, which essentially means you're paying by the unit.
Right.
And that's happened, to your point, in electricity. It's happening even in streaming music, bike share, et cetera. So it's pretty interesting point you make. So let's get specific if we can. And obviously what we've agreed is that there are great diversity, a multitude of use cases. We can't cover them all. But I'd love to get some concrete use cases into our minds here. So we could start with yours, Stuart, since you're living it.
Sure. PlaceIQ, we're a location analytics platform, or essentially a big platform for finding interesting and relevant signals that are happening in real time to an event. Right now in the US, soon to be everywhere in the world. We've basically come up with a platform to map a tile-based information grid over every square inch, literally, of the US. So our clients are, for example, in the retail space where we can show them different signals that we're seeing in real time. So for shoppers who go to one particular space may have come from, or we can show trends that they've actually been shopping in fairly regular areas. So the example that was brought up earlier about people falling in love, we can do the same thing, right? Just by knowing where if you obviously you live in a certain place, but you're going to somebody else's house at lunchtime, then marriage might be in the rocks. Now there's all sorts of privacy concerns around all of that, which we adhere to fairly aggressively. But I want to pick up the point that was made earlier about the 10%, and that's actually something. I'm an engineer by trade, background, hobby, interest. I'm not a computer scientist. I like building things, and I only want to build things that people use. Everything that we're focused on at PlaceIQ is building the platform for functional use. But as was raised earlier, the biggest challenge around big data is actually assembling meaningful data that you can actually do the science on. So just like many big data and big science companies, we have data engineers and we have data scientists, and I spend an awfully large chunk of my time trying to make sure that my scientists are not mangling data or unmangling it so that they can actually do the 10% useful work. That is probably the biggest challenge that any big data company has, and of course the more data we have for somebody like us, we sift through reams of both public and private information, and we try and pull it all together to make sense of it and then look for signals. But only we can only do that after we've cleansed the data, that we've made sense of it. There's an awful lot of junk out there, and it's only getting worse and worse. I used to work in digital library systems, and I would always joke that librarians were terrified of computers because they thought it would put them out of work. In actual fact, the librarian is probably one of the most useful people on the planet right now because they know how to make sense of data and categorize it. And that's a real skill set. And so I would love to hire a lot of my librarians to join my
You're
hiring.
for librarians.
Absolutely. But to the 10%, we are still going through the exercise where I'm trying to, I'll use every commodity tool out there to remove my ETL problem and to automate as much as possible. Because the last thing I want to do is have my very smart data scientists working on ETL challenge. It's just wasting money. And so we are, just like everyone else, we kind of race to the bottom of commoditizing all of that infrastructure. Mm-hmm. I only want to work on and pay for those interesting problems. I don't want to work on glue or anything else. I just want to.
Interesting. I am conscious of the time, but I have a follow-up question for you, and then I think there may be a good perspective, so maybe each one of you could give just a quick answer. So the universal problem of I spend too much time cleaning the data, maintaining the data, fixing mistakes, versus it's where I want it, it's what I need, I'm exploring, I'm asking questions, I'm getting answers. Do you find that some of the newer big data technology, and including the cloud, changes that at all? Do they make it worse, make it better?
Both, yeah. Yes, there are some commodity tools. for cleaning. There was a big movement about a year or 2 years ago on master data management, which I'm a big fan of, because that was really treating data as a first-class citizen. So I'm injecting some of those back in, but really it's about data steward and ownership. It's not really a tools problem. It's really understanding the data.
Yeah.
So it comes back to that
Yeah,
expertise.
it's always us human beings who mess it up.
That's right.
To me, that will never go away. It's just like, I mean, our own apartment, right? An enormous amount of time is spent just keeping it sane. And data is, I mean, even when data was clean and customer ID was just a number and the product ID was just a number and the amount you paid was just a number, was, even at that time, data quality sucked. So, and it's an enormous problem, and the less structure you put on data, and the more you're going to try things quickly, the more that will be an ever-growing problem. So to me, it's just, we won't resolve this. We'll just have to manage how much we want to clean it before we use it. And that management is already a high-level decision. I mean, that's actually requiring real skill to know whether it's worth the effort or not. So I think it will still take an enormous amount of time, whether we like it or not. And worse than that, it will take higher and higher skill to be able to do it right.
Scott, do you concur, or you have something else?
Absolutely. I mean, stop. I think the point about these technologies being kind of driver of innovation, even a wedge, if you will, with kind of in today's environment, a lot of top-down pressure on organizations to better leverage data as a strategic asset within the organization. I do think the point I mentioned earlier about structure on read helps, but you're now in a situation where organizations are trying to become more data-driven, and a lot of that means how do we better share data across the organization? All this stuff that's sat in silos for lots of reasons. And now you start to talk about kind of ramping up or amping up governance, compliance, policy, getting people to work together. It's all those hard organization problems that got in the way before and made it difficult when data was still siloed. So I think in many ways it makes that aspect of it more complicated, and organizations that are committed to it will address because the payoff is so great.
Right. Actually, you took the words out of my mouth. I think if I were to synthesize what the three of you are saying, you're saying, yeah, we're still human beings. We still have to figure out how to govern things, how to make good decisions. So in a way, it's a high-stakes situation. The potential to benefit has grown. However, that's grown partly because we have more to manage. That's going to take more time, effort, skill, thought, and oftentimes money. So it's kind of a higher stakes, but also a higher gain, if you do it right. So speaking of that, it seems as though the cloud is there, and it's certainly very attractive, and yet it's not the only way to handle data. You're never going to, especially if you're a legacy corporation, you're never going to be pure cloud-based, or it seems unlikely. How would you think about the pros and cons? This would be a great question for you, Stuart, at least as a start. Pros and cons to cloud versus local, and also how that changes as you go from experimentation, pilot, scale, evolve.
Yeah, it's a fairly timely question for us. We're actually migrating from the cloud to our own colo for a number of reasons. Largely for the same reason that every big data company has, is that the cloud economics work great up to a certain point in terms of particularly data size. If you're doing kind of raw grid computing, and you can easily shard your problem, and by that I mean scale horizontally, then the cloud works perfect for you. When you face challenges where you simply have an enormous amount of data set, you need to do a large amount of processing across that data set, and you don't have options in your model to shard, the cloud becomes a problem pretty quickly. And not only that, if the clouds do go down, we've seen some fairly famous horror stories around Amazon and other things. Now, that all gets better. I think what we'll see is Right now, the cloud is very much kind of commodity, one size fits all, and that doesn't really work for particularly around crunching very big data. And it really comes down to I/O, right? The physics of computers haven't changed in the last 20 years. You're still pushing ones and zeros through a bus onto a disk and vice versa. I think that we're going to see more appliances. I used to work at Sun for a long time. I can see Oracle kind of following on from where Sun was going with these dedicated data appliances that are actually engineered at the hardware layer, i.e. to get the CPU physically closer to the disk, because that's the problem, right? You're basically, it doesn't matter how fast your disk is, you're still running on very antiquated architecture that's from the 60s, 70s. It's still the same thing. So we'll see more of these specialized devices. For us, the economics work great, just like for any startup. For the cloud, you prove the idea, you get it going, but you actually hit Amazon's limits pretty quickly. For us, we're now, we shift an enormous amount of data. We're heading into the petabytes, so and we're having to process, we want to process in real time. Right now, our time efficiencies aren't there, so we're looking at specialized networking inside of our colo in order to bring CPU closer. Now, my expectation is that somebody will commoditize that, and as soon as that's ready for me in the cloud, with GPUs, for example, then I'll push it back. But right now, I have to solve the problem that we have.
Interesting. So I would glean from what you said that you're certainly you find very appealing the variable cost structure,
absolutely,
the ability to sandbox, and you have scaled quite a lot up to the petabyte level.
That's right.
But at some point, there's some of these downsides like speed, certain types of processing, hardcore analytics.
And I think we've used it effectively for the playing, right, to figure out what will and won't work, and that's where it's beautiful because. You do need to be able to fail, and I'd rather fail on something that I can then wind down extremely quickly rather than fail on my dedicated capital expenditure of a colo. But we've now figured out the problem that we're trying to solve, and now we need to optimize for it. We'll still keep the cloud for playing and discovery, where we can again wind down should we go down a path that we then want to backtrack from.
Thank you. So maybe we can go to Edward for additional thoughts on kind of the pros and cons and the considerations. And then I'd love to have you wrap up, Scott, in terms of the decision criteria that you recommend on that.
Sure. The cloud, there are different meanings to it at this point, right? There's do you deploy in Amazon, the public cloud? You deploy in a private cloud? There was a very mysterious concept when I arrived at Tengen. What's this notion of a private cloud? And so Goldman Sachs is actually building a private cloud of MongoDB as a service. And so what's the idea behind that? Why don't they just do it in public? Well, they can't do this on a public cloud because they have very sensitive data. If there is any problem with Amazon that gets breached, then they're responsible for the fact that they put data and made it vulnerable. So it's not even a question of whether that model works technologically. It's a question of data security, and it's absolutely inconceivable for them to put the data outside. Okay, so then what's the advantage of a cloud? The advantage of setting up a cloud themselves, right? It seems like it's the worst of both worlds. Well, the advantage is that then, as a developer, if I'm on the business side and I'm just trying to build my application, then I can just ask very simply, give me a MongoDB. And they have built already a private cloud that basically says, okay, here's a bunch of MongoDBs available, and okay, this one's for you. And then I can just start working. And think of what's the alternative. The alternative is I'm on the business side and I say, okay, I want a MongoDB. I go to my IT guy and I say, okay, figure out what it takes to get this MongoDB going. Well, okay, it takes a bunch of servers, it takes some bandwidth, and it takes the setting up all this software. Okay, great, do it. And then suddenly he has to sort of purchase hardware, and it's not even the problem of money, it's the problem of the amount of time this is going to take when you're in a large enterprise. You're essentially talking months at best, right? And I've actually seen projects where the hardware purchase step is half a year. And by that time, the poor business guy is like, on to 3 other new projects. So that means that the ability to answer him, if I'm on the IT side, I'm going to provision this, and of course, it's not going to be perfect. It's not going to be the exact settings that that will be able to serve everyone. But I can provision something that is sufficiently general purpose so that then when they come and say, well, I can give it to you right now. I can give you this right now. It's not perfect, but you've got it like this afternoon. As opposed to, we'll make it perfect, it will take 6 months. He knows exactly what the answer that he's going to get, right? He's like, I'd rather get something now that's imperfect than something perfect in 6 months, because perfect in 6 months has no meaning. In 6 months, what's perfect is going to be something completely different.
One clarifying question. How would you define private cloud, and how does it differ from the mere notion of setting up a purpose-built data warehouse that happens to be remote and easy to configure and roll up? What are some of the attributes?
Private cloud is, I own it.
You own it.
I own it. Nobody can possibly get into it aside from me.
I understand.
So what's the problem on Amazon?
Yeah.
The problem on Amazon is that I get my virtual machines, and I get my virtual storage, and I can even get some I/O, some provisioned I/O operations per second to my storage. That's great. If just when I need it, which is of course peak time, also for somebody else, just when I need it and I really need this throughput and my app to work to impress my customers, somebody else also needs this bandwidth and this storage and this computing power. And to impress his customers, he's going to hog the bandwidth as well. And suddenly we're both hogging the bandwidth, and suddenly the bandwidth is terrible for both of us.
Got it.
And that is very unpleasant.
Greater control, obviously, because you own it.
Exactly. Private cloud, it means somehow, okay, I have the convenience of being able to provision on demand, but I know that I can put some rules saying, on this machine, I'm the only one.
Gotcha. Thank you. Thank you. Scott, what do you think?
So just a couple. I think the security questions have been generally addressed. At least with our clients, we see if people are open to it. The cloud providers can convince them that their security is going to be just as good, if not better, than what they can get through their own implementation. So I think that's certainly used as an argument within organizations and against cloud providers. But I don't personally believe that it's.
I think it's a legal problem more than a technical
Possibly, and
problem.
who owns the risk?
Right.
Certainly.
The law may be lagging the reality to your point.
That's right.
So, I think clearly there are, and so it comes down to, a lot of these issues that I've already raised up in terms of you asked about the decision criteria. So, performance characteristics, real time or very low latency, probably not going to be cloud-based. Certainly anything where you might have situations where you're running an always-on Hadoop cluster, probably isn't going to work well in a cloud implementation versus maybe for that situation you'd have a hybrid environment where burstiness happens in the cloud. I mean, we've had clients that have looked from, just in moving from an on-premise to a cloud-based implementation around big data, in particular one who has a kind of market data management and analytics environment that drove their costs down by about 90% in moving to a cloud-based infrastructure. So as a product owner, that's millions of dollars a year. You can do a lot with that money. So, if you can get your head around, performance and, some of these other issues, then there's certainly some huge advantages in going that direction. I think the other one we see is operations and operational simplicity. We've had clients that were just 5 nines in terms of operating traditional monolithic technology environments. As soon as they started looking at Hadoop and managing their own Hadoop clusters, the whole thing fell apart.
Right.
And so, being able to get that through a cloud provider as a service lets you kind of avoid that type of pitfall.
Because you may not have in-house capabilities having to do with all these brand new technologies.
Yeah, well, and I think it's really how again, we're talking more about large organizations have optimized IT operations over the last 10, 15 years.
Legacy environment. Interesting. I have a question I guess it's either for our host, because it's your building, or for Eric, because it's your organization. But we started a little bit late. Are we able to go a little bit beyond 7:30, or do we have a hard stop? Oh, good. Okay. Because this is interesting, and I would hate to start rushing people inappropriately. But moving along, so we've gotten a few examples of use cases. Well, actually, I think the closest was yours, Stuart. But to broaden this and help us get our mind around it, really briefly, so we can conserve time for some other really interesting questions I'm about to ask, can you each just give maybe 2 use cases that preferably are diverse and specific that you've seen either with clients or in the marketplace, or even that you anticipate seeing?
Shall I start?
You have the mic.
So one use case is from a manufacturer, and they make tractors. And what's interesting is that tractors are pretty high-tech beasts right now. They have all kinds of sensors, and these sensors report where the tractor is and what the tractor is doing and what the tractor is, sowing, whether it's fertilizer or seed or whatever. And so the farmers use the tractors, and then all of the data from the sensors is uploaded in the cloud. And then the farmer is able to, that data is processed, and the farmer gets to see the map of his land and where he went with his tractor and what happened, and given other information like the weather and what happened on his land in the past, whether what he did was optimal or not. And whether he should actually put more fertilizer in this particular place or put more other things. I'm not a farmer, so I have no idea what I'm talking about. But there seem to be all kinds of decisions that he can
Water,
that he can do to optimize his yield, and he can get this information in real time while he's on it, so that he can correct his course and action while he's in the field. So that's amazing, because these manufactured products, that manufacturer had no relationship to the farmers before, right? And now he's providing a product that is immediately actionable, and he is so valuable that he can sell this product, this data service.
Right. It used to be a dumb tractor, a piece of machinery.
Right. And now this is, and that's an incredible data problem, because you've got this massive amount of data being uploaded, and then it has to be processed into something meaningful, because otherwise you just get a bunch of latitude, longitudes, and weird action codes. And turn this into a map that's color-coded and giving meaning so that you can act on it, right? The whole problem with analytics is not gathering data. It's not even the analysis. It's actually making sure that that it provokes an action. Until analytics create an action, you've only wasted money, right? So, and that's the real hard part, is making sure that some action is taken at the end. So that's one use case. And another use case that is perhaps surprisingly difficult. The MetLife has an interesting story with us, where they traditionally had a policy-centric view of the world. When you call MetLife, you had to give your policy number in order to be able to have information about what's happening with this policy. If I gave my name, they wouldn't be able to know how to link it to different policies. And they wanted to solve what seems like a simple problem. If I give my name, they want to know what are the policies that I attributed to. There are some policies that I may not even know about because they come from my employer, and I may not even know that it's a MetLife brand. And making this match is remarkably difficult, right? Getting to the point where I can call one number at MetLife, and that person whom I talk to ends up knowing all of the policies that are related to me, so that then they can talk to me intelligently about everything that I have with them, and perhaps even how to propose useful things to me rather than proposing things I already have, is remarkably difficult. And it took, with classical technology, 2 years and $20 million to get nowhere. And with very flexible technology, new kind of cloud-based technology, it took 6 months and 1/10 of the money. So it's incredible what it enables, even for what appear like very simple problems, right? Because what's hard here is that you had 20 different IT systems from 20 different brands that they had purchased over the years. They have different formats, different technologies, different systems, different cultures. How do you get that data to be integrated in one place? If you've worked even with one IT department, you would know that it's very hard to do that within the same IT department. With 20, I can see why, with 10 years, they would get nowhere.
So they in your observations, benefited significantly from a cloud environment, and briefly, why was that so much better?
What was so much better is the representation of data. So one thing about the NoSQL databases and our database in particular is the fact that you can represent data as a document and being able to not specify ahead of time how that document is structured.
Right.
And to be able to, in a relational database, to be able to put the list of policies that are attributed to me is very hard. Imagine doing that in Excel, right? How many columns do I put in? But if I can just specify a document and give the flexibility of putting an array of the policies that are really for me, then that different model changes everything. Suddenly it's much easier to resolve this problem.
Yeah, that's an interesting use case because in a way it does something that in the old days we thought relational databases were a way to get organized, integrate, link keys. But there's a use case now where at times you can be more agile with essentially data integration problems using NoSQL, not only SQL.
Absolutely.
So Stuart, you've
So-
seen a few of these cases.
I'll try and refine it to two. This is a Fitbit. Many of you may have it. It's a device, I think the beginnings of what we may see in terms of collecting massive amounts of biometric information on us. And this device tracks my steps. It gives me a calorie count, tells me how many calories I've burned off that day. So I can set myself a target, and it gives me a nice report. There's a dashboard on it. To your point about dashboards, so this is a kind of hot topic of mine. Dashboards again are useless without actionable insights, right? And so what we're doing now is collecting tons and tons and tons of data, right? This thing will collect. I have a nice little JSON stream coming out of it. It actually feeds into a Mongo database of mine.
Yes.
There you go. But right now, I don't know all of the interesting questions I want to ask of that data. I haven't figured that out yet, and so that's where your structure comes in, right? I don't need to structure it right now. I just need to know that I'm collecting it. At some point, I will have some time, and I'll write an interesting program to ask queries of this data. What are my patterns? Do I walk more faster on a Tuesday rather than a Wednesday? Things like that. Ideally, what I'd like is to get this information over to my insurance provider so that they can give me a decent premium. The fact that it's all about data-driven decision making, and I hope that we get to that point, because that requires a whole bunch of other hurdles around people and legal and everything else. My second use case is with the UN. There's a fantastic project that's driven out of the UN here, which is Pulse. Some of you may know about. Absolutely amazing. So they were actually the people. So they're a network of hackers basically that sift through both public and private data. Again, for the UN, looking for signals, the signs of stress anywhere in the world. And they do that through looking through Twitter feeds and others, but correlating Twitter feed messages to cell phone signals to anything they get their hands on. And they are true hackers in the sense of the word, in that they hack cell phone signals in order to get some of this information. The Red Cross were able to get to the disaster area in Haiti faster than they'd ever got there before, because the UN project found that signal faster than anybody else. It actually was faster than obviously the news agencies or anyone else. And it was because Haiti had a very rich mobile cellular network, and they could see the signals of distress. Help, my building's just collapsed. I'm trapped, right? If 3 people next to each other send out the same signal of help, my building just collapsed, you're probably in an earthquake. And they figured that out very quickly, and they sent that signal in. So that's and that was again using that particular architecture that they built is a massive cluster of compute framework that's specifically for filtering signals, and it can spin it up and down, again, because of cloud infrastructure.
Yeah, the UN Global Pulse
Great.
thing, which is probably just really getting started, is just fascinating.
Yeah, they and very, very smart hackers.
Thank you.
Thanks
Thanks for bringing that in, Scott.
I'm going to try and sneak 3 in, so I'm going to go through them quickly, but happy to answer questions after. So one of our clients, NetApp, we've been working with them on building out a Hadoop infrastructure to capture phone home data from devices they have out in the field. So you can imagine for support, getting all of this data in and being able to run different analytics processes against it. We had actually I was on a panel like this, and one of their customers, not knowing we had worked with NetApp, mentioned that as their use case example where they had seen support times drop from several weeks to a couple days in most situations. So real tangible kind of impact in terms of that system. But where it gets interesting is you start to then look across products. So it's not just looking at one product family, but across products, join it with CRM data, and you start to build these 360 views of the customer. And you can light up other use cases, for example, around sales, where they're looking at clustering different customers, and by seeing where the outliers are, they can target sales opportunities and better focus their sales and marketing around outliers and where kind of customers or potential customers should fall within that map. So that's one. Another one, I can't mention the name of the client, but it was data science work with them. They operate a good part of the internet, and they want to look at, with all these transactions, all this data they're capturing, what can they do? What new things can they do? Where can they find new meaning, new insights? Where can they create new business value from that data? And one of the most compelling ones that we were able to find was around security. So they process several hundred billion transactions a day. They want to look at a particular type of malware attacks over the internet, command and control botnets. And we were able to go and identify, again, through some clustering algorithms and looking at kind of chattiness of these botnets over the network, we were able to identify sources of these botnets 6 months, and that was the extent, that's as far back as the data went, 6 months before any of the security authorities were publishing those botnets. So here you have big data giving a 6-month lead time on potential security threats to organizations. And the last one's a personal one. It just happened last week. I had a trip out to California. When I landed, fired up my phone, the first Google Now card I got. So those of you on Android, Google Now has this with the latest version of the OS. Google Now cards, it kind of makes recommendations based on browsing history and location. If you're brave enough, I guess, to turn it on. But the first one I got was directions in time to Lagunitas Brewery. Now, I've never searched for Lagunitas. I probably have searched for beer, and if they track my GPS, they probably see me in a bar every once in a while. I was blown away. It was probably, in all my history on the internet, using mobile devices, it was probably the single best recommendation I've ever seen.
Like it. Love it.
You don't get that.
So we don't have a limited time. I'd like to fit in 2 more questions and then also open it up for the audience, whom I'm sure has either follow-up or even new questions that we haven't thought of. So there's one that we absolutely need to fit in, and that is, okay, well, how do we plan, both at a high level as well as at a more granular level? How do we decide what to do, set a strategy, and also then plan and execute that strategy? How do you recommend going about that? And maybe we can start with you, Edward.
So the big data strategy?
Yeah, big data strategy, some people might call it.
I can't stand that combination of words, by the way. the big data strategy, right? Because usually when I show up at a prospect that says we're working on a big data strategy, that usually essentially means we're building a Hadoop cluster, although we have no idea why.
Right.
So at that point, that usually means, okay, we'll call you in 6 months when you may have an idea of what you're doing. But because data, I'm a data analyst, and data can be phenomenally distracting, right? And it's very easy to forget the point. And the point is action, and action to either make money or to either save money, right? But there has to be something very concrete at the end of all your effort. And so I find that the strategy really is, okay, think of your business and think of how data can support your business objectives, right? Start with business objectives and then data understanding. And it's not data you may have, it could be data you could have, and we can think through that, right? And think about how that can support your business objectives. And then figure out basically the technical aspects of how to try to leverage that. I mean, what I found beautiful in this trivial example of integrating the weather in the e-commerce site is clearly somebody thought right in that company. Somebody thought, it's raining in London and you're showing me bathing suits on the homepage, and I'm sure this guy called the e-commerce executive and said, "What the hell is this? Right? What? How can this happen? I'm never going to buy this. I don't even want to click." And that generated a whole new stream of integration that was very productive. And it required a very strategic thought that was really well grounded to sort of bypass all the technical obstacles and difficulties, because often, no matter what we say about how great this all is, it often can feel like a slug through mud, right? And it's important to remember to think strategically before you execute, and to remember in the end that you want to act and measure. Often, no one measures. They just want to act and then talk about it. But they don't measure what it actually is the impact. Often the first time around, the impact is negative because you're not going to get it right? And if you measure, then you can start learning, and then you can start doing it right. And those who have the most interesting stories are those who have gone 2 or 3 times through that cycle of iteration of learning and improving. That is effective, right? And the cultures who are able to really push and incentivize innovation, it's really hard, because it really means, if you're pushing innovation in a company, that really means you're allowing your people to fail. And it's very uncomfortable to fail in front of people who are paying you, as you know, right? So to enable that is very hard. And it really takes a lot of examples. A lot of example and enablement and technology to help you there, to allow you to fail and improve. That's my
Thank you.
conclusion.
And if I can zero in on what you said last, and then we'll go to Scott for a counterpoint or an elaboration here. You have to try a lot of things and fail, especially in certain parts of strategic renewal and growth, right? Let's say that I'm a business, I have something that I do well, I want to keep doing that, but there are some new opportunities I may not have even found. So there's that strategic frontier of discovering. And it sounds like what you're talking about is you need projects that are set up to enable rapid cycle testing and failing. Once in a while you succeed, and you also need a strategy for what you're going to do when you succeed. And I'm oversimplifying in the interest of time. So on the one hand, in most corporations, it's understandable that you go before someone and say, okay, I want $1 million to spend on technology and data analysts. They would say, well, I hope you have a plan to succeed with that. And you're saying, well, actually, you need a plan to try many things, mostly fail, but eventually succeed as a result. So if I could turn to you, because I know you do a lot of strategic planning, Scott, how do you square that circle between the understandable desire of companies to know that they're going to get a good return on investment in, let's say, doubling down and spending more on doing the right thing with data? How do you square the circle with the fear of failure, with the need to fail?
Yeah, well, I think in large organizations, you need some use case that pays the freight. Right, so whether it's 90% cost reduction on infrastructure, or something that's just not working today, that's a critical part of some business process. Yeah, that justifies the initial investment, and then everything after that gets you into kind of bonus time, right? I think just underscoring this kind of theme around the acceleration of the innovation cycle. I mean, I think it's absolutely critical, and something that Edward hit on, to have business involved in that discussion throughout. Because if you look at, and I'm generalizing, but the old way of doing things, where a business person would come up with a hypothesis, they'd call one of the SaaS analysts who lived in the basement. 3 months later, they kick something out. Maybe it was right, maybe it's wrong. Business person moves on to the next thing or iterates. Well, a lot of the promise of the infrastructure is you've now shrunk that cycle down to not months, not weeks, not days, sometimes hours, right? But to really drive innovation around that cycle, you have to have business working together with the analysts and the technologists to deliver on the capability and deliver on the promise of being able to innovate that quickly. The other thing, and just getting on the soapbox a bit, I think one of the real challenges facing the industry right now is the lack of tooling, and the fact that you need data scientists to do a lot of the interesting work. And absolutely critical, that will always be critical around research analytics, But over time, you really need to be able to push these capabilities out to the hands of the business. So, the cycle's happening at the coalface, right? If the people who are working with customers every day that can test hypotheses, see what the data says about it, if there's promise, if there's meaning, bring it into action. And if not, move on to the next one. And so I think there's a lot of investment, but right now, the kind of the tools lagging, infrastructure is holding larger scale adoption back. Absolutely.
Interesting, right? Well, okay, I have many questions I'd love to ask, but I think we should really democratize this just a little bit. And, Eric, you can call time when you see fit. Yes?
I had a quick follow-up question on the earlier discussion on data cleansing and mapping and structuring it and ingesting it. So I get that for structured data and relational data, so some of the biometrics data, for example, you're collecting. I get how you may choose to structure that. How do you deal with voice and video?
Noisily.
Do you want to take the mic, Stuart?
Yeah.
What
So
particular
let me
use case do you think?
let me just kind of use case in fraud detection
Okay.
within financial services. We're in New York.
Did everyone hear the question? I'm sorry to interrupt.
Go ahead.
No, okay. Thank you so much, Scott, for reminding. So the question was, how do you deal with video and audio in terms of processing and preparing for useful analysis, and the use case specifically being
An
fraud
example may be
analytics.
fraud detection, for
Fraud
example.
detection, as an example. Back to you.
So I actually did look into this a couple of years ago with a colleague and was warned off it in that it was too difficult to do. We were looking at voice detection algorithms and looking for a change in sentiment and tone for both fraud detection, also kind of a lie detection algorithm. But the problem is that it's very difficult to match your voice across different systems based on how they were processed. So if you're speaking in your voice is captured in one type of audio device and it's encoded in a particular bit rate, for example, and then your voice is then recorded in 3 others, all of different noise qualities, it's very difficult even to match your voice across those systems. They're getting a little bit better, but the algorithms themselves are quite noisy. And you can only get to, if you can only get to a certain percent match, somewhere like 70%, then there's no value, right? And it's too expensive to go from the 70 to the 80% match. And if you can only match my voice across multiple devices only 70% of the time, then it's very difficult to justify any further investment in it. That was my personal experience.
Stuart, quick answer, yes, no, or I don't know. How about video? Do you have the same problem there, or?
Actually, video is easier.
Easier,
Yeah,
interesting.
video is easier just because there are a lot less permutations and the video codecs are somewhat similar.
Interesting.
There's less noise,
I had a
so
feeling.
it's a closer match.
There was a very interesting interview with a NYU professor who's working on predictive algorithms that look at things like gait, height, et cetera, to try to predict intent early stage. But he alleges in an interview that I heard that he's making good progress.
Interesting anecdote on video. I have a friend who's in digital signaling. So there's a camera on top of a big billboard, and they're trying to see who's looking at the billboard, and they're trying to count how many people are looking at it. So it feels like a simple problem where you have to detect the faces and then differentiate men and women. And if there are more women, you put in a ad for women, and vice versa. And the algorithm, was improving and was getting to something like 87% accuracy, which sounds pretty good, right? In terms of detecting whether it's a man or a woman. You could tell the vulnerability of that number at the cold sweat my friend was experiencing whenever he was making a demo to a potential investor. And obviously the first thing they would ask is, okay, let's see if it works. And that algorithm, 1 time out of 7 was basically not able to detect not able to say properly whether it was a man or woman. So
Right.
it's
Sample of one became very upset.
Value can be very elusive. Right?
And if I could, I think there's another aspect to this question, which is perhaps a fallacy or a notion that with these technologies you can just store everything, which isn't true. And whether it's 100 times less than traditional technologies, 1,000 times less when you get into some of the cloud technologies, there's still a cost. And I don't think I've had a client yet that didn't quickly figure out how to fill up the capacity that their organization was willing to pay for. So there's still these questions around planning up front, which data, are you doing some cleansing or aggregation versus just dropping everything in.
Time for another?
Oh, absolutely.
Oh, fantastic. In the front?
I had a question about real-time analytics, especially when you think about advertising from the advertising perspective. A lot of television networks and other media people who are trying to understand what's the best way to communicate to the right target audience. The good part about real time is that it's great for news productions or any kind of related to recent events. But again, the question really lies is how well can we use the data and how prompt can be with the results. So do you think that still real-time analytics plays an important role?
Yeah.
Question is about whether real-time analytics is for real. Is that fair? Okay. So I think it's a very good question because just like big data, it's a very abused term, real-time analytics, right? It can be very powerful, but not everything has to be real-time. Very concrete example. Banks, when you show up on their site, or anywhere actually, when you call their call center, they want to know what they should be talking to you about. Okay. Now, there are all kinds of analytics which are about you, like your history of transactions, your age, where you live, the type of money that's coming in, where you shop. And all of this is used to kind of figure out where you are in your life stage, what kind of social status you have, and what you're likely to be interested in. All of that is calculated in batch. Obviously, if 5 minutes before you call the call center, you happen to be calculating on the mortgage simulator with real numbers in there, that changes everything. Suddenly, you are really interested in buying a house, and you even put some numbers, and that changes the whole game. And if you can integrate that context, that should certainly update whatever else you were thinking about from the batch analytics. So there is always going to be a balance, right? You have to use the history, but then you have to use the context. But that context is not often the whole game, right? So there is going to be, just like with everything else, a hybrid there. And how much you weigh the context and what you want to extract from the context that is likely to be useful to change your decision is something that requires a lot of experimenting.
Stuart, I suspect that your very business model addresses this question.
Well, so I've been involved in ad tech for a couple of years now, and so lots of ad tech companies are looking at this, and I think I throw it back to the same thing that I think all three of us have said is that what question are you trying to answer? And real-time analytics, the only reason for putting in that kind of firepower would be, on the ad space, would be that you want to influence that person's decision right there and then, right, based on what you know about them. So we've seen, promotional Twitter handles go into TV campaigns, and it then says, right, go to the web to get the rest of it. There's lots and lots of, they collect a lot of information, stats on how effective those things are. As close as I can think of as an example for real-time analytics in ad tech would be, the Minority Report situation where you're walking past and a billboard, it actually doesn't just know what sex you are, but knows who you are, right? And then tailors a product specifically at you right there and then. We are actually, at PlaceIQ, we're actually investing quite heavily in real-time analytics because one of our product spaces is mobile advertising. So we know where you are, who you are. We know that you just walked into Walmart, right? So that's very valuable information to Walmart. We also know where you come from. So in our case, we have the power to influence the decision right there and then in real time.
And to just sort of reflect back what you're saying, the batch question is know as much as possible about who I am
Sure.
already.
Yeah.
But there's very important new information, perhaps the crux of your very model
Yeah.
is where am I now?
Yeah, and the real-time side of it is much more kind of rules-based, trigger-based, whereas the batch is where the real machine learning.
Right, so in a sense you actually
train the
have-
system, you build up the profile, and then once I've got the profile and the rule set, then I can execute in real time.
Right, and so actually you did much more complex analysis in advance, and
Yeah.
then you were able to take a very quick rules-based, just a little bit of logic, says, boom, Best Buy.
Yeah.
This guy is probably
That's
a
right.
TV buyer.
It's just trigger-based. Yeah.
Interesting.
Yeah.
Scott, do you want to take the question as well, or shall we just throw it out there again?
I think it was
It was
pretty well
answered,
covered.
I must
yes.
say, absolutely. Well, these are just fascinating. Yes, sir.
In terms of technology for real-time analytics, what kind of technology do you guys look at, and what are the preferences, and what do you guys choose to use? It's more for storage.
So real-time analytics, technologies, I'll leave that one.
Are we talking about real-time analytics or the question of cloud-based big
Yeah,
data?
real-time, so it's stuff like storms.
Yeah, so I was going to say Storm.
Okay.
Yeah, so.
But you guys moved back to Oracle, like more relational. Did you say that, like, because you want to do real-time analytics, you guys have to move from a cloud-based solution
Oh.
to a...
Yeah, so we are moving to our own colo because we need ownership of both the data, because some of it, well, a lot of it's sensitive, but we need much finer grain control over the CPU itself. Like we're down to, with the likes of Storm, we also use functional languages. We're going back to C and C++, and even assembler in some cases for really high-speed throughput. And I think that we'll see a big growth in that. Actually, I'm actually surprised that there aren't many more C++ machine learning frameworks because we're now most of the use cases are breaking these frameworks. We have to scale horizontally, which is expensive, rather than invest in a more efficient processing regime. So I think that's something that we're going to see coming out, I think, towards the end of this year and next year.
Brief follow-up question that was triggered by this excellent question, and actually for Scott. I'd like you to comment on a disconnect that I'm sure has a good answer between the case of PlaceIQ, where they kind of tapped out on how well their needs were being met by existing cloud technologies relatively early on. I mean, they're still a fast-growing startup, just got another round of funding, but this is not a massive company yet. Meanwhile, it sounded like you've seen much larger companies actually moving the opposite direction and do okay. Can you comment briefly on why those companies could save money, whereas he's actually leaving the cloud, and partly for financial reasons, but I think partly just to get what you need.
Right.
Is that accurate?
Yeah.
What are your thoughts on that?
I think it's actually pretty straightforward. In that Stuart talks about the performance requirements and
about
the
the
legal
needs,
issues.
yeah.
You know, so
Gotta do what you have to do.
Yeah,
Yeah.
I think in any of these situations, you're starting with the requirements and constraints and going from there.
Would it be safe to say that there are some generic needs that can scale much farther, where you can actually do, hundreds of petabytes, thousands, and still save money? Or where's the boundary? He commented the boundary was kind of that you run out. He said something to that effect. You run out relatively quickly as you grow.
Yeah, and I think perhaps that's maybe the difference between a single organization versus a company that's providing a service or a platform
Yeah.
out to the market at large, where their scalability requirements are going to be, you said you have to, the way they have to scale is going to create much higher performance requirements than what typical enterprises are going to see.
It does come down to business goal, role of technology, requirements, just like it always has. Time for another question. You've been waiting.
Oh, thanks. So first of all, for Scott, we need to know, did you go to the brewery and how was it?
The question was, did you go to Lagunitas Brewery?
Well, so that was part of the only beef I had with this. It hit me with that recommendation as I got off the plane going to a meeting. So if it were really smart, it would have hit me at about 6 o'clock that night. I was thinking about what to do. Well, it does,
It does,
but it's not that smart yet. But it was still good enough.
The other question is, on this notion of tools and kind of democratizing data, so everybody in your workplace has access to all these data stores. It seems to me there's a bit of a tension. On the one hand, you do want employees to be able to go and look at sales data and make their own graphs and ask their own questions and answer it. On the other hand, I've talked to IT people at companies that say they are constantly deluged then with requests from people. How do I do this graph? How do I do that? Or can you get this data for me? And they're playing whack-a-mole with all these data requests, and it's hard for them to, get enough blocks of time for them to do their own projects. So anybody who has ideas on that.
The question was, how do you address the problem that comes with giving people access to data, which is that you have a lot more questions, a lot more support, a lot more
Data is
confusion.
distracting. Right?
Distraction.
So I don't think there's a simple answer, and I think it's the tension we talked about earlier. Is the first step is getting it into an infrastructure where the company, any of the users in the organization that wants access to the data can get to it, but there's regulatory and legal and other constraints as to you can't just open it up to anyone, and so there's some heavy lifting around understanding those types of requirements, putting in place governance policies, role-based access control around the data, different types of interfaces for different types of users, whether it's APIs, query interfaces, however they get, at the end of the day, you want to make it as easy as possible for people to get the data they should get access to.
I think there is also something pretty clear. The people who need the data are business people, and giving them a command line, giving them an API, giving them an SQL, giving them a Mongo query interface, all of that is just completely foreign to them, and there's no chance they'll ever use it, and no chance we'll ever get them into training to use it. So there is a reason why you have an entire layer of business intelligence tools which are constantly trying to improve in order to make it easier to talk to the data when you're not a technical person. You can be very smart, you can be very mathematically oriented, you can be very quantitatively oriented, and not be a IT technical person. And that is a hard gap to bridge, right? And you have a growing industry of mechanisms, tools, and training of people through various careers to essentially enable them to talk to data without having to deal with all that stuff that feels natural to us but is not to most people who need the data.
I'll just add one. So in my experience, when people come asking for data and you give it to them, the next question is, what do I do with this? And you just say, open up a can of worms. So my first question is always, what are you going to do with it?
Yeah.
And also, if I give one person one view of that data, there's lots of different ways of looking at data. There's lots of different insights I can draw out of it. If their colleague then goes and looks at the same data and infers something different, I've got a problem. And so it's not just a whack-a-mole IT thing. It's let's make sure we're asking the right questions. Why do we want the data in the first place?
Right. There's a theme of governance here that you just can't get away from, which is more assets, more investment, more processes, more need to govern those. To your point, why do you want it? What is the business goal for which we've even given you this data? Interesting. It's a good question. Yes.
Yes, at my company, Courses, we spend a lot of time building infrastructure to store data for customers who feel that this data might, at some point in the future, be valuable. But right now, they don't know what to do with it. So what sort of specific tools do you guys like, either favorite tools or tools you recommend, to help identify patterns in the future without a lot of upfront investment required? So either mid-sized companies that don't have the resources to hire an army of business analysts or invest in major real-time analytics platforms. What specific tools would we recommend to these folks that will give them a head start when they're looking to identify patterns in the future very quickly and cheaply.
The question was, to paraphrase, what tools do you recommend using to better understand the potential value from data that you have but haven't figured out how to use?
You know, I mean, I think there's a lot of, you know, exploratory BI visualization tools out there today. Almost every one of them will claim integration with Hadoop or integration to some of the cloud-based platforms. And different tools have different strengths and weaknesses. So I'll give you the consultant's answers. It depends on what they're trying to do. I mean, typically with clients, they'll have a set of legacy tools, and to the extent they have skills in those tools and they'll support what they're trying to do, then absolutely stick with them. If they don't have a strong legacy preference or they're finding they're not gonna, or we don't think they'll meet the needs relative to new infrastructure they're putting in place, then we'll make a recommendation on something else. But there's a lot of them out there.
One of the cheapest things you could do is normalize your data and then turn it into a competition on Kaggle. You get a whole bunch of free data science work done for you, and some press, and I've done it before, and it's there's some very good data scientists on that side.
Let me challenge you a little bit on that question, right? If the question is, what kind of tools can I do to discover something interesting about my data? My instinctual reaction is, you're asking the wrong question. And if somebody comes to me saying, give me the tool that will be the answer to my problem, I would tend to say, well, your problem is that you haven't really defined your problem. And until you have, it's like the guy who wants a big data strategy. Right? He doesn't yet have a problem. He just has a wish to follow the trend. And so what I would do in this case, because it's perfectly legitimate to not have an idea of what to do, right? What I would do is actually give it to a consultant and say, okay, your job is to find something interesting for me and make me excited. Right? And then once I'm excited, then presumably I would have some idea of what to do, and then we can start thinking. If the tool should enable an idea, a strategy, something that I'm very clear as to what I'm going to act, how I'm going to act. And until then, the question is a little bit opaque.
You asked a great question, and what I found fascinating was 3 very diverse answers from 3 really interesting guys. One says, well, it depends, that's true. One, I love the Kaggle recommendation, and in a way, what
which is like sharding the consultants, right?
Right, you're saying sharded to a consultant. But you also raised something that, Edward, you and I both feel very strongly about, which is unless we know our problem or our business model, what the key drivers are of that business model, that context is absolutely essential before we can actually look for opportunity in data, because we should be looking for opportunity to improve those key drivers of results. So I guess I would just want to say, let's assume for a moment that you do know what the problem is, because that might happen sometimes too, right? The problem is marketing ROI.
Well, I'll give you the case study that we have in mind. So we provide services for a variety of clients in different industries. One is healthcare. So company that's collecting a tremendous amount of data on drug pharmacy transactions, and the initial use case is, well, we want to track this against just some basic transaction data, but also there's an opportunity here to correlate those purchases against clinical outcomes. We marry that with their clients' hospital databases. So the business domain is known. There are clearly going to be relationships that can be leveraged and utilized, but they don't have a specific idea of how quickly to test out those hypotheses.
Understand.
They don't have an infrastructure and expertise in place, because these are often mid-sized companies, to act on those hypotheses when they uncover them.
Well, I see Eric. He's probably about to give us one more minute. I just wanted to...
One more
question. Oh, okay. I just wanted to give you a few names because for some reason Scott didn't say them, but data discovery tools like, I'm not endorsing any of them, Tableau, Spotfire, What are some of the other ones that different people like? JMP SaaS it depends on what you like to do, really. But the space is kind of called data discovery or insight discovery, and obviously it depends on the use case too. There are more advanced things that you might need in certain cases.
You said it depends twice.
Did I? Oh no. But at least I gave him a few tools that he could check out. Some of them have free demos. Okay, one more question. Yes.
I had a question about the cultural aspect that you talked about. So you talked about the fact, and I agree with this, that it is sort of up to the company's culture. Are they going to start using data in the right way? Are they going to start doing something with it? Are you finding that you are getting interest in providing solutions and counsel to line of business leaders, or is it happening from the top in terms of people coming to you and asking, what do I do with this? How does it work? And potentially, are there issues then if line of business leaders are coming and trying to make change in the organization from the bottom up versus top down with something like data?
So yes and yes, and that there's.
Did everyone hear the question? Sorry to interrupt. The question was about audience, wasn't it?
No, I heard it as kind of
Corporate
pressures
culture.
within the organization, culture, and kind of how it's changing, and around becoming more of a data-driven organization.
Yeah, and just, to the point of being allowed to fail, it would seem, I guess, intuitively that makes sense within sort of at a divisional level, but at a higher company level, that might not be the culture. So how do you sort of bridge that divide between top down, bottom up, to be able to take advantage of some of the benefits of doing big data right?
So I've seen companies that are doing some very innovative things around data. So things like data challenges, right? To start to build kind of awareness, and so they'll put data sets out, on their network and just make it open for people to, they'll do a 30-day innovation challenge, right? Or and so to answer it directly, we see in some organizations very top down from the CEOs, probably getting asked by the board because they're hearing stories about their competitors, which a lot of times are just stories. But if competitor A is supposedly leveraging data as a much more strategic asset, you better do something, right? And then you see it kind of trickle down. These are larger organizations, and kind of the corporate antibodies get to work, and things don't happen, or they happen very slowly. But the companies that are really committed to it, they're doing it both ways. So you'll get a top-down mandate. People do the right things in terms of getting senior executives on board, on the bandwagon, talking about it, or setting some mandates, funding some things. I do think in a lot of cases, because we're dealing with new technologies, innovation, you're not going to do a big bang, right? No one's going to go and put in, 50 million or 100 million to, just, blow it out of the water and do, 100 new things. You're going to start with one or two, right? And pick those best use cases, the ones are just slam dunks for these technologies and can drive those outcomes, and then publicize it far and wide within the organization, right? And so I think it's a combination of those things. And typically within any innovative technology or technology-driven innovation, there's a lot of hype, and you kind of get into that cycle. I'm not sure if I'm capturing it the right way, but that trough where people are saying, well, it didn't live up to the hype, but real things are happening. And as people start to see those real kind of value props come into life and catch on and start to understand and internalize where the technology can be applied within their organization, it kind of catches up to you, right? In 5 years, you look around and you say, where did all this come from?
There's no secret sauce to this, right? I've seen a new executive coming in, and that's at MetLife. It was a new executive coming from another organization. That's probably why he was brought in, saying, "Okay, we're going to do it this way." And he had that legitimacy because he was new, and the whole point of his arrival was to try new things. And it somehow was able to leverage talent that was there and that was not able to express itself before, right? Or to express itself in that way. So usually there's always a combination of an executive sponsorship saying, guys, if you take a risk, I will protect you. And then suddenly those who have that talent are able to latch onto that. And then the other direction, the reason at Goldman Sachs this private cloud story happened is because there was so much pressure from developers saying, whether you're coming with us or not, we're going to use MongoDB and we're going to put it under our desk and on our own credit card, which will charge back, as an expense report if you don't help us. This is how it's going to be, right? And at that point, the IT organization is like, okay, fine, right, I'll do something. So it goes both ways, right? And the power structures in companies are mysterious and dynamic.
Well, this has been fascinating. Thank you guys so much for being so articulate, especially since it's so hot out here with the lights. Eric, I'm sure you have a few final words.
Yes, thank you. I'd like to again thank our panel and moderator. It's been great, and hope to see you again. I'd like to thank Tengen again for use of this space. I'd also like to thank Rose Klimovich. Rose, you want to wave her around over there? Rose is the organizer of our cloud track. So she's the one who put together this panel, and we'll be putting together future discussions about cloud-related stuff. And so roughly half of you are not members of the New York Technology Council. I urge you to join. You can join if you're an individual. You can join if you are Google. Google is a member, as are many individuals. So we want everyone to be involved. We think the diversity of perspectives, opinions, and energy is really important. So thanks for coming, and see you again soon.